Hey folks, welcome to lesson 22. 22. We just have one more lesson after this lesson, and it's not that bad of a lesson, so we'll finish strong. Lesson 22, hypothesis test for proportions. You believe that Hillary Clinton has a popularity of 70%. You think it's less, so you're going to do a test. This happens during election night that they think that a candidate has over 50% of the vote and they, quote, will call a state early. Well, they're doing some pretty sophisticated statistics work. Of course, they have been wrong too. And remember, we don't ever know the whole population. So this course, the ideas of this course will live on past this course. And I hope that you find it somewhat enriching in your life. All right, anyway, hypothesis test for proportions. What are the important things I need to know in this unit? Let's take a moment and hit some highlights on the notes. This unit is a lot about notation. Remember, P is a population proportion, and X is the number of people in the sample that are in the category I'm looking at. N is the number of people in the sample. P hat is the sample proportion. Remember, P hat is just a ratio, normally as a percent. Okay, there are a few assumptions that we're making in this particular lesson. Of course, we're a random sample. Now, we're assuming that the population is greater than 20 times the sample mean. If the sample mean was 5, 20 times 5 is 100. Okay, see how that works? Now, also, we have to make sure there's only two categories. It's not a third category. We're not going to say undecided. We're going to say you believe this person's favorable, you believe this person's unfavorable. Okay? Now, this is very important, this next step. The sample mean times the original claimed ratio, or the sample mean times the complement, that has to be greater than 10. So again, P sub 0 is talking about your claimed proportion. All right, let's talk about this part right here. We're talking about the method. All right, remember there are two methods, a critical value method. We're going to do the P method. It is the easiest, and it does enable you to use the calculator. Obviously, step number 1, we're going to claim the null hypothesis, and you're saying that the percentage of the population is a certain amount. And then you're going to say H1. Remember, it could be greater than, not equal to, less than. Compute your T statistic. Now, I want to rewrite this while I explain it. Remember, it's a z-score, okay? So it's going to be your P hat, your sample proportion, minus P naught, or your claim value, over, now this is what's different. This is very important for you to keep this in mind. It's your P naught times its complement divided by N to find your statistics. So keep that in mind. Again, this part right here is very important to remember, so please remember that. Step number 4, like before, you want to compute your p-value, you want to make a decision, and then you want to interpret it, okay? Interpret. That's one reason why I gave you the extra credit assignment, to help you with interpretation. This last part right here at the bottom, right here, all I'm saying is there's a calculated procedure to look for, and remember, on rare occasions, if only p hat is given, you can find your x by multiplying p hat times n. All right, I don't want to belabor that, okay? I know that you like to see the problems being done, but those are the notes, and I hope that that's a good little review for you. All right, let's keep going. All right, a real problem. Okay, let's get serious here. Your statistics instructor claims that 60% of the students who take her elementary statistics class go through life feeling more enriched. For some reason, she can't quite figure out, most people don't believe her. you decide to check this out on your own. You randomly survey 64 of her past elementary statistics students and find that 34 feel, that is, they continue to feel, more enriched as a result of her class. Perform the hypothesis test to determine if the proportion of students differs, that's key right there, okay, differs from 60% and compute the p-value. Based on your p-value, what is the conclusion if we test at the 0.05 level of significance? All right, so what's the claim? The claim is that the proportion of her students that believe that they are enriched is 60%, about 0.60. Our alternate hypothesis is we just want to know if it differs either way, okay? And so your proportion is less than, not equal to 60. All right, okay. Let's see. First of all, do we have an alpha level? Yes, the alpha level is 0.05. Now, we did a sample, didn't we? So you randomly surveyed 64 of our past elementary statistics students, so that's N is 64. You found that 34 feel more enriched. So they are in the category that you want, okay? So obviously P hat is going to equal to 34 over 64, okay? Now we could reduce that, okay? It's close to a half, so 0.48, something like that. All right, so I think we have enough to put the data in our calculator and work that out. Now, incidentally, if you wanted to find the z-score on your own, you would do p hat, which is 34 over 64, minus the 60 over, and remember how I did that? Is the square root of 0.6, see that, times 0.4 divided by n, in this case is 64. So whatever that number is, you'll see that the calculator will get that value as well. So again, we're going to do this on the calculator. We're looking for the z. We're looking for the p-value, okay? All right, let's see what's going on. All right, we're back at the calculator. We're going to go to stat, test, okay, and we want a 5, one proportion z-test, 5. Okay, when I do that, it's asking what's your null hypothesis proportion. And remember what we were saying, it's 0.60. Okay, how many people believed that they were enriched? 34 out of what? 64. Okay, remember we said differs, right? Okay, we're going to calculate this value. Okay, we calculated the value, and our z was what? Was negative 1.12. Okay, and our p-value, this is an important item, is 0.2616. All right, now let's compare the p and the alpha. P is what? This value is greater than that value, so cannot reject, no reject. And that means just accept the current condition. So you're going to say there is no evidence to reject H sub O. Therefore, the percent of students enriched remains at 60%. Still, that's pretty good. Now, folks, in reality, I still remember the person who taught me graduate level statistics. She was a former high school teacher like myself, Carroll County, as a matter of fact. And I remember those times. They were painful, but they were very memorable as well. Okay, you could have said there's no evidence to say that the percentage of people differs. You could say that in your answer as well. All right, let's look at another problem. All right, in this particular problem, we have an instructor, a statistics instructor, that believes that fewer of a certain number of college students attended the opening night showing of the latest Harry Potter movie. And we want to do a test. And we're going to test it at the 0.01 level of significance. So, hey, let's do this problem. We'll do a little quicker than the last one. Problem 8. A statistics instructor believes that fewer of 20% of Evergreen Valley College students attended the opening night midnight showing of the latest Harry Potter movie. She surveys 84 students and finds that 11 attended the midnight showing. Perform the hypothesis test and compute the p-value. Based on your p-value, what is the conclusion if we test at the 0.01 level of significance? All right, so let's cut to the chase. What is this about? And this is how I would do a problem. It's about the amount of students attending Harry Potter opening showing at this college. What's the claim value? 20%. So that's our null hypothesis. The proportion is 20%. She believes it's what? What's the key word here? Fewer. So go back in the problem. Make sure you're finding that. That's how you know to write that. And remember, there's our alpha. Okay, so we've got a lot of information out of the way. We know n. We know the x. Here's the p hat as a decimal. Remember, 13%, right? Okay, and she's saying 20% is the claim value, so she may be right. See this? She may be right. It is less in that case. We crank out the test statistic, and we have negative 1.58. You may remember on a distribution, negative 1.5 is over here somewhere. She may be right. I don't know. Let's look at the p-value. When we do the p-value on the calculator, we get 0.0568. Okay? Compare that with the 0.01, and what do we have? P is greater than alpha. Okay? That's no rejection. Okay? Cannot reject 8 sub O. So you say there is not enough evidence to say that for certain the percentage of EV college students attending the Harry Potter movie opening was less than 20%. Okay, folks, this is how it's done. Okay, and you could do it. This mental practice will help you, as a minimum, to get your mind around how statistics are used in life. All right, good people, don't forget your tasks. Okay, you just run down through them. Good luck on that quiz. Don't forget your resources here. I'm going to post this video right over here in this lesson 22 video spot. Okay, a lot of time is put into this. I hope you get some benefit from it. And then last, we want to talk about quiz advice. Okay, so I'm looking here at my quiz, and I'm looking over the notes here. I did this pretty recently. I did the quiz questions just like the way I did those questions. And believe it or not, I got them all right again, okay? There's only 6 problems. One about Facebook, by the way. So you want to be successful? Try to get the procedure down. Do a few problems. Take the quiz. You get 100 the first time, you probably got it, okay? You may need to review it later, okay? So that is something that I'd like to share with you. So, my advice is, hey, you could do it. Do small parts at a time. It will help you out. I hope this is helping you move through the material. 1 lesson to go, and it's really pretty easy. Best wishes.